for a moment, what I need to do is project something on the screen of your imagination. We're in 17th century Japan on the West Coast, and a little wizened monk is hurrying along near midnight to the crest of a small hill. He arrives on the small hill dripping with water. He stands there and he looks across at the island Sado, and he scans across the ocean and he looks at the sky. And he says to himself very quietly, Arayumiya, Sado ni Yokoto, Ama no Kawa. Basho was a brilliant man. He said more with less than any human that I have ever read or talked to. Basho, in 17 syllables, juxtaposed a turbulent ocean driven by a storm now past and captured the almost impossible beauty of our home galaxy with millions of stars, probably hundreds and hundreds, who knows how many planets, maybe even an ocean that we will probably call Sylvia in time coming. As he was nearing his death, his disciples and followers kept asking him, what's the secret? How can you make haiku poems so beautiful, so easily? And toward the end he said, if you would know the pine tree, go to the pine tree. That was it. Sylvia has said we must use every capacity we have in order to know the oceans. If we would know the oceans, we must go to the oceans. And what I'd like to talk to you today about a little bit is really transforming the relationship or the interplay between humans and oceans with a new capability that is not at all routine yet. I hope it will be. There are a few key points. One of them is the oceans are central to the quality of life on Earth. Another is that there are bold new ways of studying oceans that we have not used well yet. And the last is that these bold new ways that we are exploring as a community will transform the way we look at our planet, our oceans, and eventually how we manage probably the entire planet, for what it's worth. So what scientists do when they begin is to start with the system. They define what the system is. The system isn't Chesapeake Bay. It's not the Kuril Arc. It's not even the entire Pacific. It's the whole planet. The entire planet, continents and oceans together. That's the system. And basically our challenge is to optimize the benefits and mitigate the risks of living on a planet that's driven by only two processes, two sources of energy, one of which is solar. It drives the winds, the waves, the clouds, the storms, and photosynthesis. The second one is internal energy, and these two war against one another almost continuously. Mountain ranges, plate tectonics, moves the continents around, forms ore deposits, volcanoes erupt. That's the planet that we live on. It's immensely complex. Now, I don't expect all of you to see all the details here, but what I want you to see is this is about 10% of the processes that operate within the oceans almost continuously and have for the last 4 billion years. This is a system that's been around a very long time. And these have all co-evolved. What do I mean by that? They interact with one another constantly. All of them interact with one another. So the complexity of this system that we're looking at, the one driven by the sun, upper portion mostly, and the lower portion is partly driven by the input from heat below and by other processes. This is very, very important because this is the system, this is the crucible out of which life on the planet came, and it's now time for us to understand it. We must understand it. That's one of the themes that Sylvia reminds us about. Understand this ocean of ours, this basic life support system, the dominant life support system on the planet. Look at this complexity here. This is only one variable. If you can see the complexity, you can see how tiny little eddies and large eddies and the motion, this is just sea surface temperature, but it's immensely complicated. Now layer in the other 200 or 300 processes that are all interacting, partly as a function of temperature, partly as a function of all the other factors, and you've got a really complicated system. That's our challenge, is to understand this system in new and phenomenal ways. And there's an urgency to this. Part of the urgency comes from the fact that of order, 1 billion people on the planet currently are undernourished or starving. And part of the issue is for Cody, who is here, 16 years old, and I have permission to relay this number, when he, 40 years from now, is the age of Nancy Brown, there are going to be another 2.5 billion people on the planet. We can't solve all the problems by looking only at the oceans. But if we don't understand the fundamental life support system of this planet much more thoroughly than we do now, then the stresses that we will face and that Cody will face, and even Nancy, who's going to live till she's 98, will have real problems coping. All right, let's talk about another perspective on the importance of the oceans. Look at this diagram, which is showing warm waters in red, cool waters in blue, and on the continents, what you're seeing in bright green is the growth of vegetation, and in olive green, the dieback of